Hi guys, here is your lesson for 13.2, Angles and Angle Measure. Today what we're focusing on are sketching angles, looking at different units of measure for angles and coterminal angles. The first thing we're looking at are sketching angles. We can have positive angle measurements, negative angle measurements, and angle measurements that are greater than 360. So a positive angle measurement is an angle that moves in a clockwise fashion. So for instance, we have 0 degrees. Each quadrant is 90 degrees, so we have positive 90, 180, and 270. I meant counterclockwise. I think I said clockwise. Positive angle measurements move in a counterclockwise fashion. So for instance, if I were to sketch 120 degrees, 120 degrees is in between 90 and 180, so 120 degrees would be somewhere in the second quadrant. And I'm going to go ahead and draw this little arrow in purple that indicates the movement that I made. So since it's positive, I needed to move counterclockwise so that I can get the positive angle measurement. And 120 degrees is in between 90 and 180, so we are in the second quadrant. A negative angle measurement, so for instance, negative 40 degrees. Negative angle measurements move in a clockwise fashion. So this is 0 degrees. This would be negative 90 degrees, negative 180 degrees, and negative 270 degrees. So negative 40 degrees is somewhere between 0 and negative 90, so you're actually in the fourth quadrant. And again, I'm going to use the purple arrow to indicate the movement that I made, so I moved clockwise, so I want to indicate that I moved clockwise. And something that is greater than 360, so we'll say 400 degrees. This is positive, so again I'm going to move counterclockwise. So I have 0, 90, 180, 270 degrees. 400 degrees is a full rotation, which is 360 degrees, and then an extra 40 degrees. So my extra 40 degrees is in my first quadrant. And then to indicate that I went a full rotation and then some, I'm starting at my positive x-axis, I'm doing the full rotation, and then I'm going the extra 40 degrees. So this little swirl indicates that you went something bigger than 360 degrees. All of your angle measurements and all the purple arrows always start on your positive x-axis. Positive angle measurements go counterclockwise, negative angle measurements are clockwise, and then something bigger than 360, you're just going the full rotation and then some. So I think we already did we did 120. So graphing each of these, it's the same thing that I had just gone through. I'm going to go ahead and make little coordinate planes for each of them before I start actually graphing them. So 210 degrees is positive, so you are in the, you're moving counterclockwise, and 210 is in between 180 and 270, so our arrow is going to be in the third quadrant. So we have 90, 180, 270, so 210 is over there. I'm going to go ahead and use my purple arrow to indicate that I moved counterclockwise because it was positive. Negative 45 degrees is in between 0 and negative 90. So there's negative 45, and again I'm going to use my little arrow to show that I went clockwise since it was negative. And then for 540, let me redraw that line. 540 is going to be a full rotation and then an extra 180 degrees. So there's my extra 180. And I am going a full rotation, 360, and then the extra 180. So those are the sketches for 210, negative 45, and 540. The next thing that we are looking at is a different way to measure angles. We have degrees, and we also have something called a radian. So I'm going to go ahead and jump to here to show you what a radian is. A radian basically takes the radius of a circle and wraps it around the arc of a circle. So here's the radius. I'm going to go ahead and rotate the radius. So moving that to the outside. What's going to happen is this little line is going to wrap around the arc of the circle. So let's go ahead and wrap it. As you can see, the blue line is following the arc of the circle. This right here is 1 radian. Okay, 1 radian, because you're taking 1 radius, wrapping it around the arc of the circle. So let's unwrap it. So here's your radius of your circle, and wrap it again. And then from here, your starting point to here is 1 radian. So let's do 1 radian again. There's 1 radian, marked with the red tick mark. Do a semicircle, so we'll see how many radians it takes to go around half the circle. So there's 2, 3, a little bit past the 3. Let's go full circle. 4, 5, 6, and then more past the 6. So you can use radians to measure angle measurements just like you can use degrees to measure angle measurements. So it's just another unit of measure, just like you have centimeters and inches. Now what we're doing next is switching from degrees to radians. So let's say I wanted to look at 180 degrees. So 180 degrees over here, if I show that as radians, it's 3.142. Well, we all recognize 3.14 as pi, so 180 degrees is equivalent to pi. Similarly, if I start to go all the way around the circle, it should start approaching 2 pi. I'm going to stop at 359 because when I go to 360, it's just going to switch to 0. Oh, there is a 360. So 6.283 is approximately 2 pi. So half of a rotation is equivalent to 180, which is pi radians, and a full rotation is 360 degrees, which is equivalent to 2 pi radians. So that's what you're going to use to convert back and forth between radians and degrees. So if I start with degrees and I want to switch to radians, I'm going to multiply by pi over 180. If I start with radians and I want to switch to degrees, I'm going to multiply by 180 over pi. You are basically trying to cancel out what you already have. So in this case, since I have degrees, I want to put the degrees on the bottom so that I can cancel out my degrees. And that gives me 30 pi over 180, which can be reduced to pi over 6. So 30 degrees is equivalent to pi over 6 radians. Over here, I'm starting with the radians because it doesn't have a degree symbol, and you also have the pi, which is an indicator that you have radians. So since I'm starting with the radians, I want to cancel out the radians. So I'm going to put the radians on the bottom, degrees on the top. From there, your pi's are going to cancel. You're taking -5 times 180, divide that by 3, and that gives you -300 degrees. So -5 pi over 3 radians is equivalent to -300 degrees. For letter C, I have 135 degrees. I want to change that to radians, so I'm going to multiply by pi over 180 degrees. And that's going to reduce to 3 pi over 4. And then finally, I have my radians, so I want to switch to degrees. So I'm going to multiply by 180 over pi. Pi's cancel. I'm going to have 5 times 180 divided by 4, which gives you 225 degrees. So just converting back and forth between radians and degrees, just like you can convert back and forth between feet and miles. So it's just unit conversion. For this last example, we are looking at coterminal angles. Coterminal angles are angles that share the same terminal side. So for instance, I'm going to go ahead and graph the 210 degrees. 210 degrees is positive, so you're moving in the counterclockwise motion. It's between 180 and 270, so we'll say 210 is about right there. Now we can get the 210 degrees by going in the positive angle measurements, or you can also go in the negative direction. And either way, it's going to give you the same exact sketch of your angle. Similarly, you can go around a full rotation and then some. And you can still get that same sketch of your 210 degrees. So there's actually an infinite amount of angle measurements that correspond to 210 degrees, that are coterminal to 210 degrees. So when you're trying to find coterminal angles, you will be adding or subtracting a full rotation. So for instance, if I want to find a positive coterminal angle for 210 degrees, I can go ahead and add 360 degrees, which gives me 570 degrees. So if I were to sketch 570 degrees, I would have to go around a full 360 and then the extra 210, and it's still going to give me the same angle measurement when I graph it in standard form, or in standard position. For the negative coterminal angle, I'm starting with my 210, and I'm going to subtract a full rotation, which gives me negative 150 degrees. So if I were to sketch out negative 150 degrees, which ends up being the green arrow over here, it's still going to give me the same image as 210 degrees. So here's one positive coterminal angle and one negative coterminal angle. Radians work in a similar fashion to degrees. So for degrees, a full rotation is 360. For radians, a full rotation is 2 pi. So if I want to find a positive coterminal angle to 7 pi over 3, I'm going to go ahead and add a full rotation, which in radians is 2 pi. So 7 pi over 3 plus 2 pi is going to give me 7 pi over 3 plus 6 pi over 3, just adding fractions, which is 13 pi over 3. So 13 pi over 3 is equivalent to 7 pi over 3 when you actually sketch it out. For the negative coterminal angle, I'm taking 7 pi over 3 and I'm subtracting a full rotation. 7 pi over 3 minus 2 pi is going to leave you with 1 pi over 3. Now this isn't actually negative, this is a positive coterminal angle. So we have 13 pi over 3 as a positive coterminal angle. We also have pi over 3 as a positive coterminal angle. Now we wanted to find a negative coterminal angle, so I'm going to go ahead and subtract another full rotation. So pi over 3 minus 2 pi is going to give me negative 5 pi over 3. So there's an infinite amount of answers that you can have, because we can keep adding 2 pi if we want to, and we can keep subtracting 2 pi if you want to. But we have these two solutions over here for positives and negatives.